Hello and welcome. We are working on section 1.6 and 1.7 today, where we are going to use algebra to help us solve limits. So let's begin. There are a few rules that you'll want to follow when you're evaluating limits, and you can see three of them are set forth right here. This first one is b is some real number. So the limit as x approaches c, which is also a real number, of b turns out to be b. So if I have some number, let's say we have 7, then it's going to turn out to be 7 for the limit. The limit as x approaches c of x will be the value c. It's kind of like you substitute it in there. If you think about what the picture looks like on this, you would have y equals x is our function. And if I'm at c, I put in c, I'm going to get out c, right? If I put in c for x, then y will be equal to c. And so that one's kind of easy to understand. And the last one is like you can take the limit as x approaches c of x raised to the n. So you can move that power outside, do the limit evaluation, and then apply the power, and you'll get c raised to the n. All right, so let's give it a try. The first example, the limit as x approaches 3 of 5. Well, that follows rule number 1. It will be equal to 5. Think about what the graph of this looks like. If my function is 5, I've got a horizontal line here at y equals 5. And no matter where I select, this one said at 3, my value will turn out to be a height of 5. Example number 2, this function, I can just try calculating it out. So I'm just going to go 4, 2 squared plus 3. 4 times 2 squared is 4 plus 3. We're getting 16 plus 3 is 19. Down on the bottom, as we approach 1, I'm going to try and plug it in, and I think we're going to be fine. I'm going to have 1 squared plus 1 plus 4 over 1 plus 1. So I'm going to have 1 plus 1 is 2, 6 over 2. My limit is 3. So for most of these, we're able to just apply a nice substitution technique. And I believe the same thing is going to happen with the sine of pi over 2. Well, sine of pi over 2 is a value of 1, so this limit is 1. Next, we're going to look at functions that agree at all but maybe one point. And it's saying let c be some real number, then f of x equals g of x for all x not equal to c in the open interval containing some value c, then the limit will be the same. So if these functions agree at all the same spots except at x equals c, then we can basically say the limits are equal. One thing that might be helpful, we will do some factoring. So I don't know if you recall what your cubic factoring is, but I know when I have a cubed minus b cubed, I get a minus b times a squared plus a times b plus b squared. And for the sum of cubes, its factoring is quite similar to the above. We just have to be careful where we put our plus and minus. So if it is adding, then the first thing is we have adding. When it was subtracting, then the first sign between the variables was a negative. It was subtraction. And here I'm going to have a squared minus ab plus b squared. So get that jotted down. And let's give these a try. What I would love to do is substitution. And if I can substitute, that's where I'm going to head first. So I try to do substitution, and I notice that my denominator equals 0. So obviously that's not going to work. And the way to get around that is we will try to factor. So let's factor the top. It does look like it's factorable. and I'd have x minus 2 and an x plus 3 over an x plus 3. Remember, they have to multiply to the last number, and then those values have to sum to the middle number. So I chose negative 2 and positive 3. That made negative 6, and they have a difference of positive 1 for that middle term. Now what we see is this reduction of the x plus 3 term on top with the x plus 3 term on bottom, and it leaves me a new function, x minus 2. So when this rule up here talked about f being equal to g at all but x when x is c, this would be the case. So this function really does simplify down to an x minus 2. So this is what they're talking about. Let this be g of x, and this is my function f of x, and f of x is equal to g of x everywhere except when x is negative 3, because obviously x equals negative 3 does not work for f of x, but would work as a domain value for g of x. All right, so I've got the cancellation done, and now I can evaluate the limit as x goes to negative 3 by involving a simpler function, g of x, the x minus 2. And now I can straight up just substitute and come in with an answer of negative 5. Number 6. Well, that cube right here makes me wonder, is this a cube? And yes, of course, 64 is a perfect cube. So we're going to use that difference of cubes factoring to assist us when we factor here. So I am going to have the limit as x approaches 4 of x cubed minus 4 cubed over x minus 4. Do a little bit of factoring on top, and it's a minus b, so x minus 4. Then it's a squared, so in this case x squared, plus a times b, so I'd have x times 4, so 4x. And then last thing squared, b squared, so I'm going to square that 4 and get 16 all over x minus 4. Our functions agree everywhere except at 4, because my original function 4 is not in the domain. But now that I've created this new function, the limit as x approaches 4 of x squared plus 4x plus 16, I can substitute the 4 in. So I'm going to have 4 squared plus 4 times 4 plus 16. Looks like we have 16 plus 16 plus 16, which is 48. Okay, let's just keep on rolling. The next one. So factoring doesn't look like a possibility. I definitely cannot substitute 0 in because I'd be dividing by 0, so that's the easiest method is removed. What I want to do is conjugate this, and I'm going to create, it's kind of like rationalizing. So I'm going to create a companion, a difference of squares factoring pattern to multiply the top by. And that will straighten out the top nicely, because I'll have square root times square root. And then I'll have a cancellation of the middle terms. And then on the bottom, I want to multiply by the same, because then in effect, I'm multiplying by 1. And here we go. So set this equal. On top, let's do the distributive step. So I'm going to have x plus 1 plus a square root x plus 1. Then shift to the other distributives of the second term. So negative 1 times that gives me a negative square root x plus 1. And last times last gives me negative 1 over. I'm not going to distribute that x through, I'm just going to write it as the product of those two. The top, we talked about how we generated a difference of square factoring, and look at here, we get a plus and a minus. So those cancel each other away, or they add up to 0 if you want to think of it like that. Then I'm going to be left with an x plus 1 minus 1 on top over x. Oops, I did a bad thing there. I need to write that limit as x goes to 0 up here as well, because that's really the question that we're trying to solve, is the limit of these. So x times square root x plus 1 outside, just copying the denominator. Okay, 1 plus negative 1 will disappear, and I'm going to simplify this by just rewriting that and simplifying it down to x. Now what you notice is I have an x on top multiplied by x times some stuff. So x divides into x one time, and I get the limit as x approaches 0 of 1 over square root x plus 1 plus 1. Now use substitution, and I'm going to have 1 over square root of 1 is 1 plus 1, and we get 1/2. Practice those problems. Those usually take people a little while to catch on to. As well as this next one, and this one's kind of a fraction action one. And what should I do with these fractions? Well, first off, I'm kind of running through my list. If I can substitute, I'm going to substitute my values. So can I substitute 0 in for x? Well, up on top, I'd be fine on the numerator, but however, in the denominator here, it is going to be division by 0, which is not so cool. Can't really factor anything. Can't conjugate and make rationalizing problem out of it. So I think I want to make a like denominator. And let's add this numerator together. So make like denominator in the numerator. How do we do that? Well, it's not that bad. I'm going to make each one have the same denominator, and that least common denominator, LCD, would be a 3. It needs a factor of a 3, and it needs a factor of an x plus 3. So in order to generate that, I need to multiply, I'm going to take that off too. I need to multiply this by 3 over 3. Then I'm going to minus, I have 1/3, and I need a like denominator of 3 times x plus 3. So now I have to introduce the x plus 3, all divided by x. Okay, let's keep simplifying. I would have a 3 on top, common denominator of 3x plus 3, minus x plus 3. I'm going to leave that in parentheses over 3x plus 1, because this negative really needs to distribute through. Right? Another line of work. The limit as x approaches 0. I almost forgot my denominator of x. Okay, so I'm going to have 3 minus x minus 3 over the LCD of 3x plus 3. And then it's divided by an x, but that's like multiplying by 1 over x. Simplify again. I'm probably showing more steps than I have to, but I just don't want to lose anyone. So I get 3 minus 3. So on top, I'm going to be negative x. On bottom, I'm going to have 3 times x times an x plus 3. And yes, you're right, we can reduce those x's. We are getting so close to the end of this problem. You're like, about time. negative 1 over 3x plus 3. Substitute in 0, I get negative 1 over 3, 0 plus 3 gets me negative 1/9. Now, I showed a lot of steps on that, but I did it on purpose so that everyone could follow along. You do not have to show me that many steps when you're working through a problem. Probably could have done it in half as many steps, but we made it very explicit to everyone. All right, we have problem 9. This is a problem where you're going to work with x plus h. So it says find the limit as we head to 2 for f of x. And then I look over here, and f of x is comprised of 2 branches, right? It is a piecewise function. And that piecewise business starts or hands off when x is 2. So when it's less than x, I've got a linear function going. When I'm bigger than x, I have a quadratic, it looks like. All right, so I think I skipped a problem, didn't I? That skipped ahead on me. Sorry. We'll come back to that one. Let's go ahead and finish this one up. So what I need to do is I need to evaluate the limit as x goes to 2. Let's choose from the right side first of f of x. And that means I'm going to be following the top rule because I'm bigger than 2. So that's going to give me 12 minus 1 or 11. Oh, you know what? I know what's going on. I'm using the text tool, and that is not what we want to use. All right, so we plug this in, and I plugged in 2. I get 4. 4 times 3 is 12. 12 minus 1 gives me 11. For the limit to exist, the left has to equal the right, so let's check out from the left side of our function, which puts us into the yellow rule. The limit as x approaches 2 from the left, that would be the linear function 5x plus 2. If I plug 2 in, I get 10 plus 2 equals 12. And these indeed are not equal. So therefore, the limit as x approaches 2 of f of x does not exist because the left did not equal the right. Okay, back to the x plus h. The problem with x plus h. So all we really want to do, we want to let h goes to 0, which I cannot just use substitution since I have the denominator issue. So we are going to expand our terms, and then we'll simplify and see if we can get anywhere. Hopefully we can get that h to cancel away, okay? So just lots of nice algebra coming up here. I need 4 times. If I square that, that's like saying x plus h times x plus h. That will be an x squared plus a 2xh plus an h squared. Distributing the negative 3 through, I'm going to have minus 3x minus 3h plus 2 minus 4x squared plus 3x minus 2 divided by h. Looks like a mess. What I need to do is take this 4 and send it through. So let's keep, we're really kind of still expanding, aren't we? We get 4x squared plus 8xh plus 4h squared minus 3x minus 3h plus 2 minus 4x squared plus 3x minus 2. So many terms all over h. So let's look and simplify what we can. I remember as I wrote down, I had a positive and a negative 3x, so those are gone. A positive 2 and a negative 2, that makes 0. A negative 4x squared and a positive 4x squared, those are gone. And I think I've got this down to 3 terms. This term, and then that negative 3h term. Okay. So we get the limit. I don't want that. There we go. The limit as h goes to 0 of 8x plus h plus 4h squared minus 3h all over h. Now remember me telling you kind of the key that unlocks this problem is if I can simplify out that h and get rid of it. What you might notice on top, I wrote this kind of funny because that should just say xh plus, because it was 8xh. What you'll notice, conveniently, the 3 terms on top all have an h in common. So let's LCD this, factoring the h out front. So I'm going to have an h, that'll leave me an 8x plus a 4h minus 3 divided by h. Oh, that's a beauty. H divided by h makes 1. And now I can use substitution. H equals 0. And I get 8x plus 4 times 0 minus 3. Final answer. The limit ends up being 8x minus 3. Now, I know it has that limit attached to it, which makes it sound maybe a little bit more difficult. But this was just a gigantic amount of algebra when it was all said and done. And then we finally got down to this level where we could plug in 0 for h, and it cleaned up really, really nice. So that is the lesson for 1.6 and 1.7. All I'm asking you to do, I think for the first is check the calendar, but I think it's just doing circuit number 1. So what is a circuit? I can't remember if we've done these already in class or not. A circuit is a group of problems that will lead you and bounce you around. So here is my starting position. And when I take the limit as x goes to 5 of 12, I get 12. Not an answer of negative 3/8, right? No, somewhere on this board, though, is 12 for an answer. Does it look like it's on the front side? What about on the back side? Ah, there it is. That came from problem 1. That was the answer to problem 1. So I now am on problem number 2. I'll calculate out problem number 2, get its answer, and that leads me to problem number 3. We're looking for what? 8 as an answer, must be on the front side. 8, 8, 8, 8. There it is. This becomes number 3, and so on. When you get down to your last problem, the answer should be negative 3/8 if you've done your circuit correctly, bringing you full circuit back to the beginning. All right. Good luck. And that's all for tonight.